And welcome to episode 5 of Nemertes Emerging Technologies. We've got Jerry Murphy and Marc Seybold here, and I'll let Jerry finish the introductions.
Well, that's it. I'm Jerry Murphy at Nemertes as well, and we welcome you to this Emerging Technologies talk on Cobots. And I will let Marc talk a little bit about the agenda, then we have a quick presentation for just a second.
So here are the themes we're going to run by just in case people aren't familiar at all. What are they? Who's using them? Some of the people that are making them and future directions. And to kind of level set, we've got a short video from a company that's got a client that's using these things, not one of our clients, but it's a nice introduction to them. And I think Jerry can tee it up.
There we go.
And here we go.
Based in Ashland, Oregon, Derek's is a fourth-generation family-owned company that makes drill and knife sharpeners on fast-paced production lines with many repetitive and ergonomically unfriendly tasks. The company has now implemented universal robots in screw driving and box erecting applications.
The reason that I got into automation is each year we add more and more products to our product line, and I need to be able to add that capacity in the same amount of space and with the same amount of people. The reason I don't just go get more employees is we kind of live in a small rural valley. We have quite a bit of competition as for the labor pool that exists. I started looking into universal robots. They appeared to be simple to program, or I realized that they were collaborative, meaning I can have people work next to them without a bunch of caging, and the price was very competitive.
All right.
And we'll go back to the actual more boring part of the presentation.
Well, for us, it'll be, I'm sure, very exciting. Here we go. Back to the slides. There we go.
Okay, and next slide. So they're not the C3POs that people think they might be. That illustration is actually a Boston Dynamics Atlas. And despite all of the slick YouTube videos that they put out, the machines aren't actually commercially available. These things are still kind of in the R&D mode. The systems that they have put out, Spot, people are probably familiar with it. It's the robot dog. And we've got a slide on an automatic truck unloader machine that they have built. Doesn't look anything as interesting as this does, kind of like a large elephant snout that reaches into the truck and puts things on conveyor belts. But it's very useful. We're probably not going to see the human form robots until somebody figures out how to give it enough smarts and brains and safety systems to make it something that could be out in the streets or the factory floor with us. So they're working on them, but they're not here yet. There's a kind of dichotomy in the cobots, because there are small ones like the ones that we just saw that are used in lightweight manufacturing, and then there are somewhat larger ones that are used in more industrial environments. They straddle the line between the kinds of things that do have to be caged and are dangerous for people to be around, versus say like the 5 kilogram loads that are normally considered the machines that you see in offices or small industrial runs. They're very often used in production cells where you've got to change things rapidly. So the larger machines that you often see in automotive factories or large aerospace, those require extensive programming, and they're not easy to change and have them do something different. One of the distinguishing features of the cobots is you can use them for that. So if you're doing relatively small production runs or there's a large amount of variability, they're ideal systems for doing that. You also definitely want something in the range that people can work with them. So about 200 kilograms, well, 100 kilograms, around 200 pounds, 220 pounds, is about the max that tends to get defined, because that's well above what a human can lift, and it's definitely in the danger zone if there's a collision between those two. The fastest growth of all things is actually the pick and place. Turns out there's just an enormous amount of human labor that's devoted to picking something out of a one bin, doing something with it, or putting it into another bin. And there you don't really need much weight. 5 kilograms is about 11 pounds or so. And if you think that's not much, try holding, you know, a barbell arms extended all day, or just, you know, maneuvering that around, and you'll see that's already a lot more than you'd want to carry.
And it's not just the weight, but it's just the repetitive nature of things. I mean, the previous video we were just looking at, if we'd have played it longer, one of the things there is people had screws that they would, or a drill that they would use to drill into these recessed holes, and people would often miss them. There'd be 4 holes, but since you can't see into the recessed hole, people couldn't validate that they were actually getting all 4 holes. Robot is programmed to do the 4 holes exactly where they are. So the amount of errors are going to get in drilling something in a recessed area, a relatively lightweight, but it just turns out to be much more reliable for a cobot to do that type of thing.
And definitely a safety issue. We've got a slide later on where things like repetitive stress injuries are a good example of driving adoption of these systems, where somebody's just sitting on a line and doing almost the exact same motion all day. Next slide.
Don't get carpal tunnel.
Yeah, or worse. Makes tennis elbows seem like a minor thing. Yeah. Not that I play tennis, but I just hear enough about that. Let's go to the next one. So why use them? Well, the short intro video, I think he made the case really plain. There's a direct return on investment. The smaller ones that you saw in that video are now at the point where they're competitive with human labor when you take the total cost. He made the very valid point there's a shortage of labor. And when we first started digging into this, the full impact of COVID hadn't hit. And now I think the last number I saw was an amazing 11 million jobs are being advertised. It's not clear that really means there's 11 million vacancies, but even if it's 2 or 3 million vacancies, that's an enormous number. Clearly, those people aren't going to pop up out of nowhere, and robots are going to wind up taking a fair amount of those jobs. The repetitive stress injury we just talked about, that's a really classic one. High repeatability and low variation. I mean, basically quality control. That's the easiest way to describe that. Human beings get bored really fast, and the last thing we really want to do is the same exact thing all day, every day for an entire year, much less our career. Toxic or hazardous environments, it relates back to the safety issues. If you don't have to have humans near toxic chemicals or dust powders, all sorts of things in industrial environments can be dangerous to us, then the machines are an ideal substitute for that. And the fact that you can get the small ones that can do reasonably delicate work is a great step forward. It just takes a whole lot of environments where we were forced to still use people, and now opens the options of exposing the machines to it and making it a much safer work environment for the people. Teleoperated, this is kind of interesting. And again, the pandemic has accelerated this. Some of these machines require human supervision. They're not 100% automated in terms of what they're doing. It's a little bit like a Waldo, where you give it direction and are telling it or maneuvering in some way through a control system what it does. Well, in those systems, as long as the latency in the communication channel between you and wherever the robot is sufficiently small, then there's no reason for you to be anywhere near where the machine is. And obvious things like that are say, mining applications or any kind of hazardous factory work. But the point is that once these machines are present, you could be any place. Could even be in low Earth orbit in space, or maybe even on the moon. We were talking about the bounce delay would take a little bit of getting used to, but you can imagine something like those Boston Dynamics Atlas robots that right now the big hang up is they're dumb. You know, that they can do certain things that they're programmed to. They're great at balance. The company's done, you know, some amazing work. And we see that in the dancing videos, or when they take them out into the snow and they're literally on hiking trails and they're able to cover ground. But imagine that you simply had some kind of, say, a cat suit that was totally instrumented, or a whole series of video cameras and sensors where every motion that you made was duplicated by the machine. and all of a sudden it doesn't make any difference. We don't have to wait for deep learning or artificial intelligence to catch up. Those systems would become immediately usable. And that might be one of the next frontiers, because in combination with the remote work option, all of a sudden it's possible to have the human labor pool do something interesting without having to put themselves under threat, or any of the other hazards that we've seen, the repetitive stress industry, all those kinds of things.
And as a former military guy, I'm just going to throw out there, I could see a massive applicability in mobilized operations in urbanized terrain, sometimes called them out. Like you can see this robot sneaking, looking in a room before a human being's putting their head there, deactivating roadside bombs, cluster munitions, clearing minefields. I mean, there's all kinds of obvious military applications.
Yeah, anything where you wouldn't want to put a human at risk. It's just as long as they're not Cylons.
Talking to my wife about why I'm late from work again.
We were kidding. I mean, if you marched 20 or 30 of those human form robots into Times Square, it'd probably scare the living daylights out of most people. That they think the science fiction world had just arrived. Next slide, please. So coexistence means that there's no direct interactions. The robots are doing something, some part of the production, and then humans are doing an entirely different one. But they're not actually working together, even though they might actually be sitting or standing or whatever we want to describe for the robot next to each other. And we saw some of that in the video. Towards the end, I think they showed the machine actually folding flat cardboard boxes into the full shape, which was pretty interesting. Sounds like a totally boring thing, but which person wants to sit there and do that all day? Whereas the machine is totally happy, and then a box gets handed off to, in their case, another machine that actually fills it with boxes. So sequential collaboration, we saw some of that on the line. Humans and robots are going back and forth to do the complete task. So maybe the robot is doing the really boring part of assembling the box and putting those screws in, and then the human is fitting a wiring harness. Might be an example of that.
Matter of fact, in the case we were showing you, showed later in the video, is the robot makes the box, inserts finished product into the box. Then there's a conveyor belt goes by a weight stand, and if the item doesn't make the weight specification, it's kicked to the side. You continue assembling with the next thing in the assembly line, and then the human being takes the rejected thing and figures out why did it not make muster. So it lets the human do the human things. Why did something go wrong? And then the robot just continues with the assembly line, and as long as it passes check, continues manufacturing.
Exactly. Cooperation is exactly what it sounds like. Both the machine and the humans are working on something at the same time and staying out of each other's ways and not hurting or damaging each other. And then responsive collaboration is kind of interesting. Not sure how many examples of that are floating around, but these are the categories that people look at when deciding whether an application is usable by these systems. It's where the robot is, in a sense, holding the screwdriver or the light for the human being. It's actively monitoring the tasks and then stepping in and doing something where it sees that the human needs help. That's probably the ultimate end of where this goes until you get to general intelligence and the machines can actively do things on their own. But when it gets to the point where it's smart enough to be able to watch what's happening and step in and give you exactly the help or piece or part that's needed, is the end of the line for the current generation of systems. And after that, we get into the truly intelligent ones. Next slide, please. So who's using them? Automotive, no surprise there. Electronics, a lot of pick and place, a lot of automated cobots. Anybody who's seen the clean rooms for chip fabs has seen that most of the humans in bunny suits are pushing buttons on the control panels, and machines are doing pretty much everything else. Metal machining, fabrication, we've seen examples of that. Even in the small factory was a good system for that. Plastics and polymers, the same thing. Food and beverages, a little bit surprising. And then other is that generic category, everything that doesn't fall into any of the others. And surprisingly, when it comes to the smallest of the robots, that's the dominant group. It's just a huge selection of niches that are applying these things. And it's very much under the radar. I mean, one of the things that was surprising in looking at that video when Jerry found it is the ordinariness of that facility and factory. They're just the kind of things that you could do or see any place. They're not a Fortune 50 or 100. They're not building moon rockets. It's not a very high-end environment, and yet it was totally practical and doable for them to implement these cobots. And that's probably got a lot of economic and policy implications. I think a lot of economists think that that kind of thing is still a decade away, and policymakers even further away. And it's not. It's here and now today.
And again, one of the things we didn't cover on that video you saw was they've actually are using the Cobot software as the focus of their whole manufacturing process, because they found it was so easy to program and tie into the whole situation that they use that software from the Cobots to actually coordinate their entire manufacturing process together, because it's just easy enough to put other things there, even if they're not inherently things that the Cobots are doing. So that's actually become the integral part of the actual entire assembly process.
Yeah, I think that he mentions that they started with one robot, and eventually they just kept adding and adding as they saw how easy it was to program them. Those machines, it's really interesting. Programming is not done by typing code someplace. You simply grab what you can think of as the fingers and put it down in the spots where you want it to do something, to give it instructions about what you want it to do, and it replicates those motions. So it's very, very doable for line workers to simply show the machine what they themselves are doing, and then any fine tweaking can be done through a graphical interface. So I think one of the women had something that looked like an iPad, and she was using that to fine tune it.
I think about the Big Bang Theory when one of the guys was like had a robot arm and he was giving Penny a napkin, but he had to like type for 15 minutes the code to actually hand her a napkin. So they've progressed a lot.
They've made some progress, yes. Next slide. So this is an aerospace example. The picture is actually from Lockheed Martin, and it's part of what they were using to assemble the X-29 Quest. That's a project that NASA's got to try and build a supersonic aircraft that makes such a small sonic boom at ground level that you can't hear it, that it's inaudible. And it's a one-off aircraft, and this is a perfect example of using them in cells. It's a little bit hard to tell. The shiny aluminum stuff you see in front is the actual thing that's being assembled, and then the arm and that kind of square boxy shape behind it is the robot itself. What's interesting about these, they're Corbas, which I, for the life of me, can't remember now what it stands for, but they're actually mobile devices. The robots themselves can trundle themselves from cell to cell. They're not statically bolted to the ground or don't have to be moved by people. And they have an enormous amount of flexibility in terms of what they can do. So they can do some milling, drilling, I think some of them laminate. It's a very flexible environment for structures that require a lot of different kinds of work to be done on them before they're completed. Not a whole lot of public disclosure in the aerospace examples, but that's not surprising given what they do and the competitiveness of it. I mean, think about the airliners. There's really Airbus and Boeing when it comes down to it, and neither one of them wants to give away the secret sauce to the others.
And I'm just going to throw out there, it's probably Cobra, because when I'm looking at the picture, it says Cobra in the picture, which is, I'm guessing that's probably Cobra.
Maybe. We'll have to look it up, or somebody can Google and post it.
Cobra called Cobra.
Next slide. So this is the logistics example we were talking about earlier. It's actually the Boston Dynamics machines. And you can see what happens. These exterior conveyor belts are actually kind of accordion type things that open and close. So as the machine starts at the back of an 18-wheeler unloading, it's almost completely closed. And as it advances into the truck, it just drags the thing behind it and it opens up. Turns out that unloading 18-wheelers is a really unpopular job. It's super hot, about as boring as it can get, and fairly crowded. It's often not possible to get more than 1 or 2 people in there. And the trucks are coming 24/7. So this is, I think, I have to go back because DHL just signed an agreement with the Boston Dynamics people for these things, and you don't see it in the illustration, but a single human controller that's kind of like a supervisor to make sure that the robots don't tip over or start doing anything crazy can monitor something between 5 and 10 of these. And if you've ever seen the bays in large warehouses, some of them are 20, 30, even 40 bays. So it gives an idea of the efficiency improvement you're going to get out of these things. And plus they can run 24/7 with a single human person watching them. They can unload trucks all day and they don't get tired. The most interesting thing to me when I was researching this is they can only unload. They're not at the point yet where they can actually be used to load. That Tetris game of fitting all the different size boxes in is still beyond them.
Which is interesting that you say that, considering in this example, all those boxes appear to be exactly the same size. But
yeah, because I think this is actually a publicity still from the Boston Dynamics company. But if you sit through the video, though, they didn't make it quite that simple. There are different size boxes that are in there. This is a still from that.
Yeah.
But it's still interesting that it's an easier thing to unload than to load. You'd think that there's some kind of symmetry in that, but there isn't.
Well, I would think that it is fundamentally would be easier to unpack something than to pack something from a Tetris perspective.
Yeah, you just figure after all these years of artificial intelligence and visual recognition systems that somebody would have gotten a handle on that. But,
I would think my gut would tell me that couldn't be that far into the future to do the packing. No. Especially if all the packs are rectangular. If you put some degrees of freedom, you restrict. So they'd be different sizes as long as they're rectangles. Don't put
I'd be willing to it. This would be the perfect thing for a company to run a contest on. Just like ages ago, Netflix was doing contests for the recommendation algorithms, or when DARPA did the original contest for the self-driving vehicles. I don't know if you remember that. The very first year, everybody was just laughing because nobody got much past the starting line. I mean, literally, they were crashing into everything and flipping over and whatnot. And people thought, this is going to take 10 or 20 years. And yet, I think in the second year, they actually had one vehicle that finished the entire course. And by the third year, nobody could have imagined watching the first year that the progress would be so fast. So I think you're absolutely on target there. That these things are going to be filling the boxes pretty quickly.
Yeah.
So this is an automotive example, and you might not think of it as a cobot. It's an exoskeleton. But that's exactly what cobots are supposed to be, right? They're working with humans and helping them. So in this case, it's not necessarily smart, but it's a muscle and strength augmentation system so that you can do repetitive motions all day without inducing the kind of stress where you get things like carpal tunnel or pulled tendons or tendonitis. And you can see how small it is. It's very lightweight. This particular one is designed for upper body strength. And that also is a nice equalizer in the labor market because historically there were jobs that were more open to men just because of the upper body strength. And now this is an equalizer. It doesn't make any difference. Takes away pretty much height requirements as well. As long as there's something for a person to safely stand on, they're now able to do the same thing.
Well, I think they also have things that can augment your height, right? You can wear stilts and things as well. So,
yeah, I mean, this is a kind of partial exoskeleton. There are full exoskeletons that look a whole lot like smaller versions of what Ripley climbed into in one of the Alien movies.
They definitely use them in the military because I've seen military applications where you can see, say, an infantry soldier wearing a full exoskeleton and just a normal sized person can sit there and squat like 600, 700 pounds without a problem.
Yeah, you do. I've seen some of those demos where they eventually stop, not because they're tired, but because they're bored.
Yeah.
The machines themselves are taking all of the weight, so you don't get any of the muscle or joint stresses that are happening without it. You also see them in the construction business, and for the same reason, a lot of heavy stuff. I mean, nobody wants to move pile of 50-pound sacks of cement from one side of the site to another, and so we're seeing these things, and it's kind of interesting because both the partial ones that we see in the automotive example and the full ones that you were just talking about, how long before they're fully instrumented and AI learning systems, after getting hundreds or thousands of hours worth of training data just from sitting there and sensing what the person is doing, get to the point where you can take the person out, especially for the full exoskeletons.
Maybe we can now have gorillas as pets. We just got to wear this when we're playing with them.
Yeah. Okay, so the forces affecting future directions. I'm going to let Jerry handle this one. Jana usually did it when we were doing the joint presentations.
Okay, well, there's clearly areas that we see, and just based on what we talked about in the utilities, you can see there's natural areas there. Medical devices, there actually been tremendous advances there. I mean, you've seen this in the last year and a half, tremendous growth in using of prosthetics, natural interfaces, and it can start from something as simple as your things on your feet and extremities to ear and eye augmentation. I mean, there's been some pretty great growth there. Marc and I were kidding a little bit before this on the consumer devices. We certainly are seeing things like Roombas in terms of robots. You can see them expanding. You've probably seen in supermarkets the ones that are more like the size of a full-size vacuum cleaner that can just basically go down aisles and clean things. That obviously carries right into things like industrial devices. It'll be interesting to see what happens as a result of having these things, how people like OSHA, who does the standards for industry safety, how they potentially are going to have to change or modify their regulations to take into consideration, well, do I change my standards for weights or proximities if I have these types of devices available? They're clearly going to have to make some changes to the regulations to accommodate the presence of these types of devices in there. I was kind of talking cheekily about playing with gorillas, but I mean, does this extend to the point where you can actually do things like muscle augmentation? Who knows? And clearly on the entertainment, they've spent a lot of money on using this type of technology there. I mean, we certainly can think at the very earliest days of the opening of Epcot Center, where you have the Hall of Presidents with what were really pretty bad types of robots, and you're getting increasingly more and more realistic things there. Most recently, they have the Avatar ride. Wish I'd gotten on it. I mean, I was there maybe 3 years ago, and I think the line was like 13 hours to get on the Avatar ride. But I mean, they are absolutely pushing the envelope with using this type of technology just to enhance the end user experience and make more and more exciting events for people that participate in.
Yeah, and to follow up on the exoskeletons and the medical applications, the exoskeletons, it's easy to forget, but their original impetus was for people with spinal cord injuries, to enable them to be able to walk. And it's only when those technologies were good enough to be usable that they started to migrate out of the original medical application for it. But it's interesting for the control systems, because the holy grail for prosthetics is to be able to simply have the system somehow either with physical implants or just be able to sense without having to do any kind of surgical insertions of sensing devices, think what you want to happen, and the prosthetic behaves exactly like the original limb or body part, and extend that into the industrial environment, and especially the kind of remote cobot things that we were talking about earlier, and that's a revolution.
And it's not just for, I mean, we've been talking a lot on how does an individual get augmented somehow, but let's not forget in medical devices, look at the tremendous advances that have happened in surgery, right? Where it used to be you'd have to cut somebody completely open to do heart surgery. Now they have low, minimally invasive surgery where you just have small insets to put in robotic devices, and then you have the surgeon that's sitting there augmenting the devices remotely. They can see everything. And now you can do these complicated surgeries. You see it with gastric bypass surgeries. You see it in open heart surgery or various types of heart surgeries, which used to have long healing times, where now somebody can literally recover in days instead of weeks from some of these surgeries because of the use of this technology, really minimizing the invasiveness of those types of procedures.
Yeah, we don't have any pictures of it. Maybe we'll add them for future presentations of this, but cobots in medicine are almost a topic on their own. And the ability to do robotic surgery, like you were just describing, it started out exactly as you described, where the surgeon was still in the room and the machines were right there. And now it's been extended out to remote locations where you can have specialists do the surgeries, and maybe they're in New York City and the machinery in the hospital is in Alaska.
It's incredible.
Yeah. So future directions. Right now, the systems are actually kind of limited in their sensory data. Most of them have small cameras, and that's what they're using for accuracy of position. Once the person has programmed the thing by locating the general area where they want it to do something. But ideally, if we want these things to work with people, we need them to duplicate all of our sensory inputs and maybe even go beyond that. It's easy to imagine what happens if you can see in infrared or ultraviolet, or you add ultrasonics and are able to see things that we can't. Like a medical application of that if you've been in the hospital or donated blood, small handheld device, and it actually will allow, looks almost like a science fiction medical scanner. So you can pass it over a limb, and it makes it possible to see through infrared where the veins and arteries are underneath, so that IVs can be put in very accurately. But extend those kinds of senses to the robots, and all of a sudden they'll be able to do things that we can't. And that's why that cooperative example in the earlier slide is kind of like the end goal, because in the ideal situation, the machines are augmenting what we can do. So we still provide the raw general intelligence that's outside of the machine's capabilities, but they can have sensory systems that are non-biologic and totally technological based, and that would help them to do things that are impossible for us to do by ourselves or alone. Space-based manufacturing, an obvious one, and that's in there because if people have been tracking what's happening with SpaceX, or they saw NASA roll out the very Apollo Saturn V looking space launch system earlier in the week. SpaceX has got a monster rocket called the Starship and Heavy Booster. And what makes it interesting is they've got a 30-foot payload fairing, which is absolutely enormous. The biggest ones around now, I think, are around 7 or 7.5 feet. And 100 tons to low Earth orbit on a totally reusable system. So all of a sudden, things that people thought they might be doing in the 2040s or late 30s or maybe even out to 2050, they're rethinking that, and they're starting to say, well, what happens if Musk is serious and he can get the price of those Starship launches in the same range of Falcon 9 that's got an advertised price of 67 million. So let's suppose he pushes it up to 100 million, nice even number. The GAO just put out an estimated cost per launch of SLS of over 4 billion with a B. And it's got less capability, and it's not at all reusable. That's mostly why it's so expensive. Everything is expended. You lose everything in that. So $100 million for 100 tons on a 30-meter fairing to low Earth orbit. And with refueling that much to the surface of the moon or Mars, obviously be more expensive to get to there because of the extra fueling. But we're not going to be sending hordes of people up anytime soon. It's going to be robots. And that could be a really interesting future. So if you're in college right now, or just out of it, you might want to give that a second look.
I know when I was growing up doing my electrical engineering integrated circuit design research, one of the things they talked about 20 years ago was, how big could you make integrated circuits? You think about these silicon wafers, and you're kind of, the biggest ones you see today are what, 10, 11 inches. Part of the limitation of crystal growth is gravity. So if you eliminate the gravity requirement, you just think about the yields you could get and how big could you make silicon wafers if you didn't have the gravity issue that you have on board here. That's obviously, there's tons of details on how do you actually manufacture. But if you had zero gravity environments, I'm sure there are many other things besides silicon wafer manufacturing that could probably get a huge boost from the zero gravity environments.
That particular one's a good example, though, because it's super high value.
Oh, yeah.
The costs of getting things up and down look like they might collapse. Where life probably gets interesting is if you can get it down to 100 pounds to low Earth orbit. All of a sudden, at that point, manufacturing becomes quite viable.
Right.
Cobot swarms. I mean, this is kind of interesting. It's a little bit like, say, if you're on a construction project and it's falling behind schedule, what's the standard response? You throw bodies at it, get everybody in there at the same time, and hopefully they're not all in the way, or if it's a high-rise building, standing on line waiting for that one elevator to get them all to the top. But cobots that can coordinate with each other is definitely something that's coming down the line and people are working on. And for that, they have to be more mobile, don't have to look like a C-3PO, but they could be something like the Aerospace Example, where it's a self-propelled robot with a manipulator and visual sensors and other kinds of detectors. Automatically breaking large projects up, something that right now, humans do a lot of that in terms of how can I manufacture this thing? I've created the prototype, right? So how do I get to the point of breaking this down into the bits and pieces that can be assembled and still keep the whole thing manageable? So it's possible that as we get to more and more cobots and regular robots and artificial intelligence, that we could actually do the CAD designs, and then the physical instantiation of these things from start to finish would be handled by the machines. And the last is kind of interesting. It's the extension of Six Sigma, right? When you've got humans, nobody wants to do the kind of paperwork and tracking that's involved in doing the statistics for, well, collecting the data that goes into the statistics for something like Six Sigma. It's just boring, and it's outside of the job that people are doing. But the machines don't care. The cobots can do that. And that extends across the range from whether the cobot is doing all of the work, or it's cooperative, or it's doing the help of the human. It's a good example of something where it can step in and take another part that's not strictly mechanical, but it aids the manufacturing process. All of a sudden, it's possible to find out, where are the problems coming from, and what do we need to do to up the quality of the things. And hopefully the answer is not always going to be, well, put another robot in there and get rid of the person.
Although with the labor shortages, there are some circumstances where that's not necessarily going to be a bad thing.
No, there's like, if you want to extend the idea of cobots to, say, platooning of the 18-wheelers and trucks, I was reading earlier in the week that right now there's 60,000 vacancies for long-haul truckers. People simply, it's not a fun job. You're away from home a lot. It's got all the negatives, and it's definitely on the boring side. And that's an example of where they're looking at breaking up the route, so that the self-driving trucks that are available can do really well on the highways, but they can't handle the off-highway part of it. So they're looking at rejiggering the supply and logistics chains so that humans would take the trucks to a staging area very close to the highway where they'd probably be dedicated on-ramps. And then the same thing at the other end of the run, where there'd be dedicated ramps that would go into holding areas where humans would take over. And then humans would do that very last part of it. And that would stay more interesting. They'd obviously be able to do it as a regular job and go home at night. And it's probably safer for everybody. It's kind of an example of where you could get a win-win, because if you have the trucks are completely automated, right, all of a sudden now you can have them run overnight. And that's a huge boon to anybody that's driving cars on highways, whether it's, inside city or near city centers, or the long haul parts. It's pretty dangerous mixing cars and large trucks. It's a significant source of accidents. So all of a sudden now it's safer for the commutes, and it's more pleasant, and there's more room. 18-wheelers take up space of, on average, something like 4 cars in stop-and-go traffic, or even more. So your commute might even get a lot better. It's a really nice situation. I think we're coming up on 4 minutes left, so let's see. No code and voice programming are some of the frontiers that are going on. We're already at the low code part, as we were talking about before, where people just simply pull the robot's fingers and pointed at what they want to do. Prosthetics, we talked a little bit about also. Any breakthroughs at that end are automatically going to translate back into the cobots and the exoskeletons and those kinds of things. And so one of the things that makes the cobots interesting, and I guess we can stop the slide deck here because the other slides are all about the future directions, and we're talking about that right now, is that it's kind of like some English words or nexus points. Tank is a really good example of that. If somebody says the word tank, so what pops into your mind? That could be an air tank, it could be a gas tank, it could be a fish tank, it could be an army tank, water tank, all sorts of different things.
My wife's perception of my performance.
Yeah, and exactly. An extension that's not physical, but it's a good example of whenever I throw the word tank out and have people do that free association, there's always new ones that come up. And cobots are kind of like that because they're in a synergistic environment with those other technologies, everything from the prosthetics to the exoskeletons to the sensory systems for direct neural control of these devices. And there are some things that or even outside of that, like one of the hot topics is to replace the mechanical actuators in all of these systems with artificial muscles. For one thing, it makes the machines very quiet. All of a sudden, there's no clanking or electrical whirring that's going on. They can be far more energy efficient. Some of them are actually recouping up to 80% of the energy expended when they extend the muscle to when they come back and relax. So all of a sudden, you can either get far more battery life out of something, or you can make the battery much smaller for whatever it is you're doing. And the state of the art are already stronger than human muscles. They're just not ready for prime time yet. But so cobots are something that people should definitely keep on their radar because their impact is very large. There's definitely economic and policy issues. There's also just new opportunities. What happens when it becomes possible to set up a factory in an environment where it wouldn't normally be possible to hire enough people to do it? Or maybe you've got access to capital, but you don't have the operating expenses to justify it. Whatever it is you're making is going to have a fairly extended runway takeoff before you're generating enough revenues to do it. But if you can buy capital expenditures, the machines, it's possible to come up with the financing for that. And you've got more slack in terms of how much time it takes before it becomes profitable. So rather than seeing this as something that can turn people's lives upside down and put a lot of people out of work, it's probably better to look at the opportunity side of it. How many new things, new industries, new factories, places where you never had factories before. Like New York City, my hometown, used to be well known as a light manufacturing city. That's what it was before banking became the dominant things. We could bring that back.
Yeah, and the great news is the barrier of entry economically is lower than it's ever been, right? So just like computers 50 years ago, the only people who could afford them were the largest companies, and now you get a massive computer in your iPhone for a couple $100. I think the same thing's happening with cobots. You really saw manufacturing restricted to like the largest automotive companies, and now you could be a small mom and pop shop, and the barrier of entry is very, very low now. So I think that's actually exciting, huge potential for entrepreneurs or people who want to do incremental enhancements. It just doesn't the barrier of entry is lower every day.
Yeah. And with that, I think we're reaching our time limit. So we do want to do the Nemertes pitch, which is actually usually the last slide. I think collaboration tools, next-gen collaboration tools is going to be episode 6 for the people that have been following us. And there it is. So that'll be April 5th at noon. We're trying to keep it the same time and same day of the week. And with that, Jerry, thank you very much. I'd like to thank the audience. Hopefully everybody learned at least a little bit. And if anybody wants to follow up, they can reach out to Nemertes directly. I think the information was on that last slide and it's on the initial one, or you can just Google us. And the company, I think only one Nemertes comes up when you Google,
Yeah.
so not hard to find us.
Right.
With that, I wish everybody a great day, and thank you for coming in and listening and spending some time with us.
Thanks a lot. Have a great day, everyone.